Okay, what I'm going to present to you is are the results of a research project that we have done for 2 years, last 2 years at the University of Göttingen. And although it has a lot to do with maps, I will depart from or move away from the actual historical maps and more come to the question of creating a modern geospatial digital model of a pre-modern street network. We have presented the website that has come out of this project as the website viabundus.eu, a map of pre-modern European transport and mobility. And here is you can see here a screenshot of this map. You basically have the lines which represent the navigable waterways and long distance roads. And there are all kinds of small symbols on the map that represent the places that were connected by these roads. And there's, as you can see, I displayed the example of the very small town Friseute in northwestern Germany here. There is a lot of information connected to it, which you can display by clicking on one of these places. Now, for the rest of my presentation, I will talk about the theoretical considerations that went into making this map, and also some of the difficulties we had with converting historical reality into a digital model. The point of departure for this project, or the initial idea of launching the project, was the idea to digitize the atlas of Hansische Handelsstraßen, so Hanseatic trade roads, from the 1960s, made by Friedrich Bruns and Hugo Wojcierka, who made an atlas with all the long-distance trade routes between the trade centers that were of importance to Hanseatic merchants. So that covers an area from Flanders, Bruges, and Antwerp in the west, covering Flanders, the present-day Netherlands, parts of Denmark, northern Germany, Poland, the Baltic states, and then westwards until Novgorod and Moscow in Russia. They also produced a very thick volume where all these streets are described into much detail. So the initial idea was that we wanted to digitize this atlas because in a lot of aspects, a digital version a digital map is much more practical than a paper version. And of course, digital technology also allows us to extend or move beyond a mere representation of lines on a map and and perform calculations with that. So we wanted to move beyond merely digitizing the roads from Bruns and Wojcierka, first of all by having a higher resolution, so reconstructing the pre-modern roads into in more detail, so you can actually look at the roads on, for example, town level. We wanted to include additional roads and places because Bruns and Wojcierka have worked from a strictly Hanseatic perspective. That means that everything that was not of importance for Hanseatic merchants was left out. So that means especially in marginal regions of the Hanseatic area, for example, Denmark or the Netherlands or Flanders, only those places were included that had a direct relation with the Hanseatic League. Whereas other, where there also existed towns and local centers that were very important from a regional perspective, or from a non-trade perspective that were not included. So we wanted to add those. What we also wanted to do was include a digital elevation model, because of course the elevation is of much importance if you're actually traveling roads in especially in the higher areas of Europe. And on the other hand, in the lowland areas, usually the waterways are a very important alternative, and even in many parts were more important than the land roads. So we wanted to include them as well. And finally, we wanted to provide a tool for the estimation of travel times and/or costs when traveling on pre-modern roads. So that means that we included information, for example, about toll stations where you had to pay toll while traveling from A to B. And also we included a very simple route planner that has some basic estimations of travel times. Okay, something about the model behind it. So if you want to do calculations on a street network, you actually have to do it, consider it as a network that consists of points, usually called vertices or nodes, which are connected by edges, the lines. And all of these elements can be weighted, so you can perform all kinds of calculations with it. From a technical perspective, if people are interested in that, we used a GIS application for mapping the lines. In our case, it was QGIS. And then we entered everything, so the geometries as well as the information about the places, into an SQL database. And from this database, the online interactive map is generated using the Leaflet JavaScript application library. So basically, the model falls apart into two categories. So on one hand, you have the edges, so the lines. These represent the streets and waterways that you can use to get from A to B. And on the other hand, you have the nodes, the points on the map, which are the places like A and B. So the places visited by or connected by the edges. And for the project, we defined it as nodes as any place along a route where something happens. So this can be, for example, that you enter a town or another settlement, that you have to pay a toll, that you cross a bridge. But also in the most simple version, a node is just a junction. So you have to choose which direction you turn. Before I will go into much more detail on the nodes, I will first talk a bit about, or elaborate a bit about, the reconstruction of the streets on the map. And here we come with the source problem, because as time frame for the map that we designed, we took the period 1350 until 1650, so the mid-14th to the mid-17th century. And here we get to the problem that if we want to reconstruct the street network into considerable detail, we do not have contemporary sources that tell us enough to do that. So we have to use other sources to reconstruct these roads. What we do have from the time period under consideration are, for example, 16th and 17th centuries maps. Well, we have just seen a couple of examples from that in the previous presentations. And as you have seen, they often do not include roads. And if they do include roads, they are often so schematical that it is hard to actually map or reconstruct them on the modern map. If we move even further back in time, so the 14th and 15th century, reliable maps are even absent, so we have to resort to written sources. And written sources of traveling usually are restricted to a list of places that are visited by a traveler, so mere itineraries. And they do not tell us something about the course of the roads between those visited places. So usually the method used for reconstructing these roads is that we depart from the written sources to identify the nodes and the waypoints on the map. We can also use these 16th and 17th century maps, of course, if they display roads. And then we have to use the earliest detailed, accurate maps that actually show the exact course of roads. And these usually date from the late 18th century. Here is an example of the Kurhannoversche Landesaufnahme. Northwestern Germany, basically, which dates from the late 18th century. Here's the example of the town of Hameln on the Weser River. And you can actually see that here we have a very detailed view of the town with all the roads leading towards it. And as you can see, like south from the town, there is a long distance road which is indicated as Poststraße, the post road. And if we can, as you can see from the course, which is quite crooked, then we might very well assume that this was also the course of the road leading southwards from town in the preceding centuries. It becomes difficult in the case of the road leading east from the town, which, as you can see, has been straightened and it's indicated by a chaussee. So this is an 18th century newly built road, which is paved. And of course, here it is the question whether this is a mere improvement of an earlier road that existed, or if it is a very newly constructed road. So here, additional research is needed to be able to map this. Well, in this case, we decided to also include this chaussee. So this is what it eventually looks like when mapped or projected on a modern map. Now, to come to the other part of the model, which are the nodes. So as I said, a node is any place where something happens along the road. So you can have empty nodes, which are mere junctions, but you can also add attributes to the nodes that describes the type of event that is happening there. And we have come up with a number of different attributes. The first are settlement in town, so they describe human settlements, or places of human habitation, I should rather say. Then we have three attributes that are related to commercial travel, so to trade. One is fair, which are usually organized in towns. They are annually organized markets. And in pre-modern time, as you might probably know, they were the focal points of long-distance trade. So the main places of long-distance exchange. And then we have the staple markets. The staples are usually towns with special privileges that allow them to force traders to travel through the town or through the marketplace, or to stay there for a number of days, usually 3. And in this period, they have to offer their wares for a sale on the local market. Finally, there's the tolls, which we have defined as any kind of fee that one has to pay while traveling from one place to another. Finally, there are 4 attributes that are related to the waterways. First of all, there's the harbor, which we have defined as a place where it is possible to switch between a waterway and a land road. So where you can actually or embark a boat or disembark a boat, or where you can load your commodities onto a vessel or not. Then we have bridges, ferries, and locks, which the first 2 are, of course, of importance when you're traveling a land road and you have to cross a water. And the locks, of course, are important if you're traveling on the waterway and you have to cross different water levels. So far, so good. That's the model that we came up with. Of course, there are a number of challenges if you want to put historical reality into such a model. Well, first of all, we have the problem of incomplete information. So there's always, the sources never describe what you exactly want to know. There are gaps in the sources. So for example, a toll station might be mentioned in the 12th century, and then it might be mentioned in the 16th century again, and you don't know what's in between. So do we just assume that the toll kept on existing, kept on being levied in the centuries in between, or did it disappear, or not? A second challenge is the variety of specifications. So if we stick to the example of the tolls, there might be all kinds of different types of tolls. There are, for example, import or export customs, which are levied on commodities. We have tolls that are levied on animals. We have transit tolls or road tolls that are levied on vehicles. We have tolls that are only levied during a certain period of the year, for example, during market times, and so on. And often it's also very difficult to decide whether what kind of toll it was, because usually it's also not specified in the written sources. Then we have the problem of temporal dynamics. So things appear and disappear, even though the situation remained pretty constant during the 3 centuries that for which we designed the map. Still, things come into being and disappear again. So we had to deal with that. And finally, there are seasonal influences and weather conditions that can severely influence the possibility to travel certain routes. So a lot of unpaved roads, that were most roads in this time, they became impassable in winter when there was a lot of rain, and they turned into muddy paths, basically, that you cannot travel with a wagon, for example. On the other hand, a lot of waterways froze in winter, or in summer, the water level was so low that you could not sail those waterways. So in order to deal with this, of course, it is very hard to include all these nuances and uncertainties into a model. So what we did was to make every element on the map describable. So we added a description field in the attribute table for every element on the map. And we also included a from and to field for every element on the map that you can use to set a date when something comes into being and a date when something disappears again. Finally, to conclude with just an example of the route planner that we came up with. It is a fairly simple shortest route calculator that, well, it just shows you the shortest route between 2 points. And it gives you just some basic information about the road, like, for example, the distance, total distance, the travel time for various modes of transport. It counts the a number of attributes where you that you pass on this route. So, for example, the number of toll stations, bridges and ferries, and so on. And it gives you an itinerary with the visited places. Now, the route planner is still the part of the map that we like to expand or like to improve in the future. At the moment, it is still very unsophisticated, but we like to include more parameters that allow for better calculations of travel times, especially. Like at the moment, the travel time calculation is only possible for land routes, but for water routes, this is not possible yet because there are so many more factors that are difficult to include in the calculator, such as, for example, flow velocity or water depth, wind directions, and such things. Also, what I have said in the introduction, but which we have not yet done, is to include the digital elevation model, because, of course, elevation has a lot of repercussions for your travel time. If you go uphill or downhill, it slows you down. So that adds to the travel time. So those things we would like to include in the future, and maybe come up with an update for that in the future. So that's where we are still doing ongoing research. If you have any questions, let me know. Thank you very much.